Hello class, welcome to Math 2A Pre-Calculus College Algebra. We're in week 7 now. Last week we finished the exam 1 and most of you completed the exam and got a good grade. I'm very proud of you. If you somehow missed the exam or are not satisfied with your exam score, please make an appointment and talk to me and I will see what I can do. If you have any questions about any problems in exam 1, you can either email me or come to my homework cafe time. I can go over the problems with you. Okay, so this week we will focus on only one section, section 3.1, polynomial functions. Not only we will talk about what are polynomial functions and how their graph look like, we will also talk about how to graph a polynomial function. So we will introduce two ways. First is to graph by transformation, and the other way is to graph by using zeros. Graphing a polynomial function by transformation is more like an extension of section 1.5, transformations. But this time we'll start with the power functions y equals x to the nth. We will have two different cases. When n is an even number, you'll have the functions like y equals x squared, y equals x to the fourth, y equals x to the sixth, and so on. And the graph of this kind of function are all kind of similar. It's a U-shaped graph. The greater your n is, the more the graph looks like a U. On the other hand, when n is an odd number, all the graphs of y equals x to the n looks like the graph of y equals x cubed. You can see they're all kind of similar. We have y equals x cubed, x to the fifth, x to the ninth, and x to the 15th, and you can see the similarity here. And we can graph some of the polynomial functions by transforming the basic forms of these two kind of power functions. And another technique we'll learn about graphing a polynomial function is to start from their zeros. So we'll find their x-intercepts and their multiplicities, and with different kind of multiplicities your graph look differently on those x-intercepts. And then we will find the y-intercept and the and behavior. The and behavior of a polynomial function assembles its leading term. That means if your leading term, I will use this example here, if your leading term is negative 3x to the 7th, then the and behavior of this function is similar to y equals negative x to the 7th. For example, this is a polynomial function, looks pretty tedious. I don't know how the graph look like, but I know the and behavior of this function just by looking at its leading term, which is negative 3x to the 7th. So how does the graph of y equals negative 3x to the 7th look like? Well, first of all, y equals x to the 7th. This 7 is an odd number, so the graph will look like kind of like x cubed, kind of like this. And if you multiply a negative number to the whole function, which is negative 3 here, the whole graph will turn upside down. Or you can say left side, right? Same thing here. So it will look like this. All right, so the and behavior is talking about when x goes to negative infinity or infinity. So we're basically talking about this part of the graph. Even though I don't know how the graph of this function look like, but I know the and behavior is going to be kind of like this and this. And the middle part, I'm not sure. That's what the and behavior is. And that is a summary of what we'll talk about this week. And I hope you have a great week. And I will see you next week. Bye-bye.